Who's going to introduce the speaker? You or me? I can do it. Okay, but then I have to read up about him. I have to say something. Where's the PG day in the schedule? I can't find it.
Hold two for today. You just click on
Rooms, all two. Oh, okay. Boom. Welcome to PG day. The first speaker is Michael. Okay, then I'll do the introduction of him. We'll be like MCs. And then after, you can sing. You can sing.
Should we wait for more people to turn out?
I don't know. It's 9 o'clock, right? It's 9:05.
I only have a very short.
Hello.
Okay, hello. I think I should introduce you to.
Okay.
Good morning, everyone. So we're gonna get started very shortly. So did you have a good sleep? Okay, that's good to hear. So are you ready to kick off our second day with FOSSASIA Summit 2025? Okay, so again, good morning and welcome to PG Day at FOSSASIA Summit 2025. So today, we're very excited to bring together the PostgreSQL enthusiasts all together, coming and sharing your knowledge and innovations, and also to help strengthen our community. So first thing first, I would like to say thank you to our sponsors, which are AWS and Fujitsu, for their generous support in making this event possible. So we're going to have an amazing lineup of talks coming up very soon. So let's get started and make it a very great PG day. Thank you very much.
Oh, you're gonna do it. Okay. Okay. Good morning, all. So just to get us started, looking forward to an insightful day today. I'm Torsten, been volunteer with FOSSASIA for about 7-8 years now. So it's great to see that we're coming to new cities every time, some new faces too. First up today will be a talk by Michael Paquier from AWS. I think I've seen your face around in some of the conferences too. Michael is a major contributor to Postgres SQL, of course, and working today at AWS. Love to hear from him about how things are going in the Postgres community. We're a bit ahead of time, so I think we can go now and then... Should we wait a few minutes? Okay, because we'd have more time for Q&A and things like that if anybody's ready, yeah? I think so, yeah. We'll try bring up the slides in the meantime. Mikhail, let me... Okay, sorry. Okay. Just on time.
And I split on that. Oh, thank you. So it's 15, right? We are beginning, so if you want to see, you can come now. Sure. Good morning, everybody. Today, to begin the set of presentations that we have in this wonderful Thailand, beginning the PG Day, I'm going to do what's called a sponsor talk, because AWS is a sponsor, so people told me, you need to do a talk. Okay. And this talk is specifically about talking about the community of PostgreSQL and how AWS works with the community itself. So my name is Michael Paquier. I am, next slide, a few words about me to give you a little bit of context. I am French, and as you can hear from likely my accent, and I am based in Tokyo now for 15 years. Since 2009. I'm working at AWS since 2022, but I happen to work on PostgreSQL for much longer time than that. If you look at postgresql.org and the list of contributors, my name is listed as a major contributor, and I work on PostgreSQL in terms of writing new features, do reviews, commit stuff, get complaints from other people about the work I do. And also I happen to have a blog which is not active. I also work as a maintainer of the project itself, as we call in the PostgreSQL world as a committer. We are currently a pool of 30 committers in the world. I am one of those today here. My colleague, John Naylor, on the first rank here. John, raise your hand. Is also a committer, and we work at the same team of AWS. So what I'm going to do today, I'm talking about the community because PG, it's a PG day. We are a community, so I want to communicate a little bit about that. So to split things a little bit, I'm going to give a few words in the community about the community itself. Just to say that I've done this presentation once in Tokyo. So people who were in Tokyo, for example, I can see at least two of them here, Inaba-san and Nagata-san. Hi. Who know this talk, but this one is a much shorter version, but I still want to drive the same message. And I'm giving a few words about how AWS works with the PostgreSQL community, what kind of infrastructure we have created, and how we try to make the PostgreSQL community greater, and how we try to do what we do. The last part is giving two examples about what we have contributed back to PostgreSQL to give you some idea about why we actually did that. But it's not only that. So just to give a few words about the community itself, about the community, this is a diagram that's not from me. It's from somebody who is working at Enterprise DB called Laetitia Lavrot that gives an excellent image of how the community is structured in terms of members. People may think that PostgreSQL is the core code itself. It's not only that. You have a structure and people around that do not only work on the code, but do much more than that. But this graph gives a pretty good image of what people do and how we actually do things on the community side. On the left side, it's what I would call the core part of PostgreSQL itself. We have people inside the core team made of 6 members. People around that are the committers in charge of the code. But it's not only that. We have people who are in charge of developing the code, developers, hackers, people who do reviews, people who do translation as well. Because PostgreSQL as a project supports, I don't know how many languages, perhaps 7, 10, I don't know. But we have people who do translations of the error strings we have, or the strings we have in the core code. So we have people, but not only that, people who do conferences, people who are, for example, sitting there in charge of the organization, making sure that we are able to do presentation like today. Like people who are there doing that are also are part of this committee and do contributions to PostgreSQL. That's what symbolizes the right part of that when you do anything related to advocacy, running meetups, users groups, working on extension, the PostgreSQL ecosystem itself, not only the core. So at large, the community is a lot of concepts bundled together to do what I would call the PostgreSQL world, or the PostgreSQL community as a whole. To give you some numbers in 2024 in terms of the PostgreSQL project for the core code itself, we have 7 core members, a pool of 30 committers. I hope my numbers are not wrong. The security team is made of 17 people, people in charge of PostgreSQL.org, 6 people. And as of PostgreSQL 17, and I hope my count is right, we have a number of 463 people who have contributed to the PostgreSQL core code for this release. It's not the extension, it's the PostgreSQL core. But there is much, much more than that. Contribution means somebody who has changed the documentation, submitted a patch, provided a review, tested something, authored something, or even just committed something like what we do when we push a patch into PostgreSQL. So to give you an idea about how PostgreSQL grows across time, on a yearly basis, we gain in terms of new C code. If you remove comments or anything related to new structures and C code, we grow by roughly 300,000 lines of code every year. The pool of committers and the number of people we have who maintain the code does not change a lot over time, meaning that on an individual basis, the number of lines we need to maintain in PostgreSQL grows over time. So we need to grow people, to grow the community, and to help people maintain PostgreSQL, and to make it scale with the way the code base has been growing over the past 15 years. The last one is 17 that has been released last September. So the second part of this talk is about how AWS tries to fit into that and how we actually work with the community itself. The first reason is, why would we actually do that? To put it very, very simply, PostgreSQL is loved at AWS, and it's what we call a strategic component. Basically, we use it a lot. We use it in a lot of ways, in a lot of integrated products that you may know about, like, for example, Amazon RDS, PostgreSQL, Amazon Aurora. There is much more than that. I'm not going into the details. The point is that we need to work with the community to help the community thrive, because it's good for the community, it's good for the users, but also it happens that it helps AWS because we can have responsiveness when we hear something from customers, users, or even people from the community to say, you could do that better as well. So to put it in very simple words, we try to anticipate the needs sometimes. We try sometimes to build the things that we hear from the customer stories, and we try to proactively interact with the community to make things happen in the PostgreSQL core code. where do we, what kind of areas do we touch, and where do we actually interact with the community? We do quite a little bit, actually. I did mention core previously, but it's not only that. The core code is in terms of new features, extensions, bug fixes. We also are involved in security. We do driver work. For example, one of my colleagues is called Dave Kramer, who does work on the JDBC Java driver, and he's one of the main maintainers. He works in the same team as us. He's not directly involved in PostgreSQL, but his work on the client part is similarly critical, because if you don't have a client, you cannot use the server and the core code. We have also extensions, infrastructure work, packaging releases, where we're involved in that. And like today, conferences, doing talks, participating in selecting talks, helping people do events, meetups. One of my colleagues, Sami Kumar, I wanted to mention his name. He is raising his hand here. He is the one who has helped in selecting the talks, right, for the PG Day today. And this is a contribution itself that AWS does back to the community to shape it. So who is actually part of the team? So this is a set of numbers for the people who are actually in the team I am working in, that we call the PostgreSQL contributor team. So currently, we have one core member among the 7. We have a pool of 7 committers among the 30 existing committers who are working at AWS now. So we try to invest in people at AWS and proactively work with the community to get things done. 4 security members, 10 major contributors. It doesn't mean that we are 20-something. It's not the sum of that. I am a major contributor, committer, security team members. We have people who do module work, advocacy as well, like Samir, who is there and is not counted there. But it's just to give you a little bit of an idea of how much we are involved based on the community global numbers. In terms of feature contributions, this is for the last 4 releases. So if you look at the release notes, you have a certain number of entries. And this percentage reflects the number of entries where at least 1% of AWS shows up. So it's just to show that for the last 2 years, since I've joined, the numbers have bumped up because somebody from AWS is involved in basically 25% of the release notes when it comes to PostgreSQL. We may have in a single entry more than 1 people listed. That's just to give you an idea that I think there was 180 release note entries in the code. 25 of them had at least 1% of AWS involved in that, listed in the release notes. It may not actually be the review, it's the author part of it, but it's just based on the contents of the release notes, because we don't quote reviewers when it comes to that. Some contribution numbers in 2024 in terms of authorship, which tracks the number of commits that have been actually authored by somebody from AWS. Roughly 10% of them. All branches means that this also includes bug fixes, installable branches that we need to maintain for 5 years on the community side, which tracks for 9.2%. Authorship is people who writes the patch, not the committer. Committer is the person who gets the patch, pushes it into the central repository. In terms of committers, we have roughly 20% of the commits that are new into PostgreSQL 17 that have been committed by somebody who is employed by AWS. In terms of all the branches, maintenance, this is 16.5%. Credit of those numbers go to Joe Conway, who is the manager of the team John and I are actually being part of. So Joe gave me those numbers just to show the impact we have on the community side. So how much time do I have left? 5 minutes? Okay, so I still have a little bit of time, right? Okay, so we may have a little bit of time for Q&A. This is the last part of the talk. I'm not going to take a lot more of your time, but just to give you 2 examples of things we have contributed back to the community based on stories and problems we have heard from our customer base. So the first one is very simple, collations. It's quite a known problem that for the last 15, perhaps 20 years, I don't know, I'm perhaps exaggerating those numbers. If you do a Linux upgrade, if you do an upgrade of ICU, well, those libraries are not very good in terms of backward compatibility. Why is that important when it comes to PostgreSQL? Simply, you care about the ordering of the strings you use. You have one string A, a string B, but what you want to do in databases is be able to sort them. You need a set of rules to be able to sort them. Those rules are defined in glibc or ICU, basically. So it means that the sort ordering is not something PostgreSQL controls. It's something that PostgreSQL outsources to other libraries, and in those cases, it's libc and ICU. It happens that those two components are not that good at maintaining ordering. So sometimes you do an upgrade of ICU, an upgrade of glibc, and you notice strange patterns showing up in the shape of broken indexes, for example, because, for example, B-tree relies on the ordering of the text data. If you upgrade an index based on a text column, suddenly, well, it does not point to what it should, meaning that this can show up in multiple ways, like, for example, duplicated primary keys because your index does not point to the correct heap tuple. While crash, the data is intact, but your indexes basically get broken suddenly. And you hear customers complaining about that. AWS has a large user base. When we have many instances, it means that we need to be able to scale with that and to automate what we can do. But outsourcing this kind of logic has its limits, even if you control the OS or what you can do. Because, for example, even for normal users, people like using their own version of ICU, libc. And we've done a little bit of work in this area to try to improve the situation. Next one. So the first one I wanted to mention is something that Joe Conway is completely crazy, really. It's what Joe has done is called the libc compatibility library. He has done a presentation about that at PGCon 2 years ago. That was in Ottawa. And what Joe has done is patching glibc and ensure backward compatibility of the text ordering subroutines we have in glibc. So you basically patch glibc, you upgrade to a new version, and using this patch, you can make sure that the text ordering that you had for an index based on the past version of glibc still has the same ordering. Basically, you upgrade glibc and your indexes are not broken. I invite you to go to this link. The slides have been given to the organizers, so this has much more details, but that's one thing that we've done. There is a little bit more to that. In PostgreSQL 17, a colleague of mine called Jeff Davis, who is also a committer of Postgres, has decided that it may not be a good idea to outsource the fact that we do the sort ordering to other libraries. What if PostgreSQL did it itself? Jeff has been working on that, and he has introduced a concept of what is called built-in collations, meaning that PostgreSQL can control how strings are sorted based on some logic that it knows about. So we do not depend on glibc or ICU when it comes to the string ordering. In order to be able to use that, you need to set up the option when you use initdb. And you say local provider, it's the built-in one inside PostgreSQL, and it works with a UTF-8. The implementation is based on a quote point ordering. That happens also to be a little bit more efficient than libc or even ICU when you do string ordering. This is based on some work that somebody named Jeremy Schneider and Jeff Davis have been doing, and this is a presentation they've been doing at ICU, at pgconf.dev last year, that gives you a little bit more insights, and I'm not going to dive into the details here. So another set of things we've been doing, it's not only that, just to give you another example, in terms of logical replication, we have heard from customers that you cannot really run a PG upgrade if you have a logical replication because data associated to logical replication slots, or even replication origins, are not copied over to the new cluster. So if you do an upgrade, it means that you need to do a resynchronization of your data from the publication node to the subscription node. Some work coming from Fujitsu mainly, led by Amit Kapila, means that we have added support for PG upgrade, and this is also some work I have been a little bit involved in, as well as one of my colleagues, Masahiko Sawada, who is now in the US. Point is that we can now use PG upgrade with the logical application setups. Your data is copied transparently as long as your origin node is at least based on 17. And yes, we also do a bunch more things, but it's just to give you an idea about the problem we had, what we heard from customers, and what we actually did on the PostgreSQL side, on the community itself. I think it's everything I had. It's a little bit shortened. We do much more than that. If you just look at the numbers, I have authored myself a little bit a few features to Postgres across the ages. So we still have time for the questions, right? Yes. So if you have any kind of questions, feel free. And thank you as well for coming in today.
Very good, Michael. Thank you. Any questions from the audience on this interesting topic and participation by AWS? Any asks? It is still early, so I understand everybody's still warming up. Yeah, but Michael, very interesting to see Amazon being so active in this space and committing. I guess long-term, this is, as you say, strategic asset, strategic initiative. Curious though, do you see, maybe just your thoughts on what could get the community more excited or more involved to become more active in contributing to Postgres? What would you recommend individuals to do to get more closer to this?
So one thing that we've noticed is that the number, I mean, it's very hard to attract new contributors into the project because PostgreSQL is seen as an old and boring technology, which actually is one of its main qualities. People like new fancy projects, and we also do everything on an email basis, which is kind of a little bit old school. We try to put a little bit more effort into working with the people, with attracting new contributors, try to educate them. If you, for example, are able to go to Montreal, which may be hard depending on what you do here, we have Discord server where we try to educate new contributors, what we expect from them. It's hard, it demands investments, but in the long term, you can do a full career on that, which is what people like John and me basically do, because PostgreSQL is here to stay. It's old, it's boring, which actually makes it good. And we have users, people who actually want it to even grow even more. Growing people to lead the community aspects is a critical piece of one big puzzle that we try to solve. I know it's philosophical and blurry line, but we try to go there and to help new people introduce new technologies. And AWS is great in providing us support to make things better. So we try to do what we can.
Excellent. Oh, a question there. Thank you.
Hi, speaking of community, could you speak about Postgres presence in Asia? In your experience, which countries are active with any advocacy or core team work? I'd be interested to hear about even ASEAN, or maybe if just Japan or Thailand or Asia as a whole, since, as we're here. Thank you.
So to give a short answer to that, Japan has the biggest community of PostgreSQL users in Asia in terms of history, mainly because we have an organization called JPUG, the Japan PostgreSQL Users Group, which is the largest users group in the world in terms of members. Perhaps Inabasan or Nakata-san know, but how many members does JPUG has? Do you know? 1,000 or I don't know. But I mean, it's kind of one of the biggest ones. Other thing is that in terms of committer pool, the existing committers, I think we have 1, 2, 3, 4 or 5 people who are actually based in Japan in terms of committers and contributors also as well. So in terms of participation to core, Japan is by far the biggest contributor to the core code of Postgres. Yes, but the country has a long history as well working with the project.
Okay, so we are up for time, but I think that's a great question and perhaps more to delve into in terms of Southeast Asia and the rest of the region getting involved. So thank you very much, Miguel. That's really appreciated. Maybe a round of applause.
And thank you for coming today. I'm here the full day, so if you have any questions, feel free to catch me in case.
Excellent. Thank you so much. Okay, we'll get our next speaker ready. If we can prepare the slides and do the introduction. Yeah. Okay. Should I do the intro? Or you do the intro? You want to do the intro? Okay, perfect. Okay, go ahead then.
So to continue our talk, I would like you guys to give a warm welcome to Kuthari, our friend from Fujitsu. So today, so please give a round of applause to Kuthari here, everyone. Thank you.
So hello everyone, good morning, thank you for being here. So in this presentation, before start this presentation, let me introduce myself. My name is Nishya Kothari and I'm working as a technical consultant in Fujitsu Singapore. And I'm the part of Fujitsu Enterprise Postgres Global Center of Excellence team. So in this presentation, I'm very excited to talk about PG role, which allows us to apply all the schema changes in a safe, seamless, and reversible manner. So as a database administrators or a database developers, we are always, worried about that how we are going to apply all the schema changes online without affecting anything. But again, there is always, because schema changes is always a risky activity, and especially when we are trying to do online, right? And that's the reason that we are acquiring appropriate downtime. And to avoid any consequences, and that's the reason that we are acquiring downtime and start to apply all the schema changes. But again, the biggest fear for the developer also is that how we are going to roll back those changes which is already applied, but due to any reason something is failed and we want to revert all the applied changes. So in this presentation, we will see how PG role will help us to apply all the schema changes online and very easily, and how we can revert back safely as well. So this is the agenda of the session. So I will start with the few basic challenges of online schema change. And then I will quickly introduce a PG role, as well as I will also walk you through a very brief how it works in a background. And then after, I will share the steps to installation and some of the uses as well. If you have any question, please ask all the questions at the end of the session. So at least I will be able to finish my presentation within a timeline. And also, I have a surprise for you as well. So after the end of the session, I'm going to ask a very simple question. If anyone is able to answer, then I'm going to give a free drone to them as well. Okay, so online schema change, right? So I'm sure many of you are completely agree with me that online schema change can be a double-edged sword, because changing structure online is always risky. It can lead to a lot of issues as well, right? And especially when anything already applied and something is failed. So it is just like, if I'm going to see a very simple example, that if it's just like, renovating our own house while every member of family is going to be, living the same house while renovation work is still going on. So there are the high chances that the things get messy very easily, right? So let's focus on the challenges. So first is the breaking changes. So when we are trying to modify or tweak any tables online, so there are the high chance that any users or applications are performing the transaction which are depend on those tables can, leads to the unexpected errors, or also leads to the service disruption as well. multiple steps. So I'm sure, again, you all agree with me that we cannot introduce any schema changes on the fly. It requires a proper planning, proper development of those changes, as well as also needs to pass a proper testing cycles before proceeding for the production. So when I say, so this particular entire process is lengthy and time consuming, also have a room of errors. So again, if I'm continuing with the same multiple steps, as I mentioned, there proper development of those changes. It's also, for example, if we are accommodating a small change, like modifying the existing column. So that particular change also requires a multiple steps in a background. So for example, adding a new column, right? So first of all, we have to create a new column. Then also need to modify our existing application to make sure that they are going to start utilizing the old and new column, both the columns for adding the data. Then backfilling the data from old column to new column. Then step number 4, analysis and creation of the constraint on the newly created column. And the fifth step is going to be like, again, modify the application code to make sure that it stop utilizing the old column and only start using the new column. And the last step is going to remove the old column. So again, if anything goes wrong and any single step for simple change of modifying the existing column is going to be failed, then entire change is going to be failed. Next one is the unexpected data lock. So when we are trying to modify anything online and we start observing that the tables which we are modifying or database start acquiring the logs, which also leads to the any transaction which are depending on those tables going to be on hold until the logs is going to be clear. So that's again also leads to the unexpected service slowness or application slowness. Next one is the no easy rollback. This is one of the biggest fear for every developers, that how we are going to roll back those changes which is already applied and we need to roll back because of something goes wrong. Right, and that's the reason as we are acquiring appropriate downtime to avoid those kind of scenarios. But again, it is the biggest fear for them. And again, we cannot be start immediately rolling back those changes. It's also required a proper planning and careful analysis. Otherwise, it can lead to unexpected data loss or data inconsistency as well. So now the question is like, what is the answer to address all these challenges? So answer is PG role. So PG role is an open source command line tool which allows us to apply all the schema change in a reversible and safe manner for all the PostgreSQL database. The PG role also supports the PostgreSQL version 14 onwards and also allows us to run the multiple schema versions simultaneously. And why it is really beneficial? Because of its offers various features. So let's start with the first one is the zero downtime. So normal traditional approach, as I mentioned, that we are acquiring a downtime to avoid consequences like breaking the changes or any database locks. But here with the PG rule, we do not require to acquire a downtime because it allows us to apply all the schema change without worrying of any consequences. So we can apply all the things while all the application users and database users are able to perform the transaction without any service disruption. Next one is the old version and new version can work simultaneously. As I just mentioned in the introduction statement that we can run the multiple versions. PG role allows us to run multiple versions of schema. So means where the old schema is going to, old version of schema represents your original schema, which do not have any modification of your changes. As well as the new version is representing your schema change, which already have your applied changes. So both can work simultaneously, and this particular approach is very beneficial when we are looking for the smooth application transition. Next one is the automatic backfilling data. So as I mentioned in my multiple steps statement that backfilling of the data from old column to new column. So generally in a traditional schema change approach, it's require a manual intervention and it is very time consuming, especially when we are dealing with the large data set. But here with the PG role, the entire activity or the entire task of backfilling data from old to new column is completely automatic and fully taken care by PG role. Next one is the instant rollback. So instance rollbacks, again, the biggest fear, as I mentioned, that for the developers always have that in their back of the mind. But here, entire responsibility of rolling back those changes is taken care by PG role. So PG role will do on behalf of you a proper planning and proper, proper analysis as well. So, so all the developers have a relax from their mind, and then they can keep focus only on the development of those changes. Next one is the work against existing schema. So there is no special requirement to make the use of PG role in your existing environment. It's very easy to use and easy to integrate, and immediately you can start utilize the PG role in your existing schema. And PG role can work on any PostgreSQL deployment. So whether you have deployed your PostgreSQL on premises or on a cloud, or even you are using the database managed service offered by any cloud provider, it works very smoothly. Even though PG role also works very effectively for any subscription-based Postgres like Fujitsu Enterprise Postgres. Next one, PG role is very lightweight because it's written in a Golang language. So it's only one binary available, and there is no dependency of any others files or library. We can also install PG role on operating system like Windows and Linux, and also possible to integrate with the CI/CD pipeline. Let's understand briefly like how it works in a background. So as I mentioned that PG role help us to apply all the schema changes without causing any problem. Okay, so first is the virtual schema using views. So instead of PG role, instead of starting modifying anything directly on a physical database structure, it will create a multiple virtual schemas by using the views. Okay, and this particular approach is going to ensure that your users will not face any service disruptions, and they can able to perform all the transactions while we are applying all the desired schema changes in a background simultaneously. Second one is the control non-disruptive changes. So as I mentioned that PG rule makes sure that while modifying or while applying your schema changes, nothing is going to be break which is already running smoothly, or I would say which is already existing. And this particular approach is going to assure that your application can able to function normally while we are rolling out all the changes in a background simultaneously. Last one is a non-immediate impact on user. So like in a traditional schema change approach, where small or single schema change can lead to the user disruption, a possibility of impact on users as well. But here, PG role will accommodate all your applied schema changes and mapped by using the views. So this particular will ensure that your application do not require immediate upgradation to make working with your schema change. So your application developer have enough flexibility, or I would say the ample amount of time to upgrade their application according to the conveniency. So this particular thing is safe to say that the PG role allows us to test drive all the database schema changes in a safe and virtual environment before making them live. PG role expand on contract workflow. So PG role is using the smart expand contract workflow to accommodate all the schema changes online. So let's start with the expand phase. So it is all about to adding the schema change safely, or I would say all about to adding safe changes. So like when I say safe changes means like adding a new table or into the existing database, or adding a new column inside the existing tables without breaking anything existing one. So if I continue with my house example, that we are planning to add a new room in our existing house without moving our furniture. Okay, so again, applications, once we are apply all the changes, application can able to start utilizing those new changes, as well as the old things are still intact and can able to perform all the work as usual without any disruption. Next one is the handling the breaking changes, or I would say risky changes. So it is all about adding the changes which might break the existing functionality. So for example, modifying the existing column. So PG rule, here the PG rule acts very smartly. So instead of modifying directly on your existing column, it will add a new column in a background and also create some few additional triggers, which is responsible to make the synchronization of your data from old column to new column as well. And this particular approach ensures your smooth transition for your application and also reduce the risk of errors. The last one is the, next one is the a new version of your application new version. So it means like, once you are done with your all the schema changes, and after that PG role will create or provide a new version of your schema, database schema structure. So depending on the business requirement or readiness of our application, we can able to start utilizing all the whole new database version at the same time, or we can use bit by bit. So again, like once our new room is ready in our house, depending on our financial budget or manpower, we can either move all the furniture at the same time to the new room, or moving one piece of furniture at a time. So depending on the situation and requirement. Last one is the contract phase, means the completing and finalizing the changes. So once we are assured that our entire application start utilizing without any issue, or start utilizing the new schema structure without any issue, then in that case we can, a PG role will start applying or completing the changes, and it will, drop all the temporary objects which was created during the period of your online schema change to make it successful, those changes. Maybe it's a temporary table, shadow tables, or any triggers. Those are created. It's going to be deleted, as well as also going to map those changes, metadata with your database objects. Again, PG, while performing this cleanup task and remapping task, PG role is also ensures that your application and user will not face any service disruptions, and they can able to perform the transaction normally. So let's understand something more with some use proper explanation, so diagram. At the time, older version of your schema is still available. And when we start applying those changes, so you can see that as active migration period. So here I have used the word according to the PG role documentation. So migration word representing the schema change. It is not the things which we are generally used for migrating from one RDBMS to Postgres, but it is representing the schema change. So when we start applying the changes, means like active migration period, during that period of a time, older version of schema is still available. Once we complete those schema change, at the same time, we can see that older version of your schema as well as new version of your schema is available for a temporary period of a time. Now, when we start going to modify the application, utilizing the older version of your schema, now our application team develop all the changes, and our new application is ready to roll out. During the rollout phase, you can see that older version is still available and new version is also available. Once after successfully completion of your rollout phase, and once we finalize our all the database schema changes, at the time you can see that older version is no more available for use in a database as well as in for the application as well. So only new version will be going to be used after all this finalizing the changes. Again, some more example with the table example. So I can see that you can see like two period, active migration period and migration complete. So as I mentioned in my previous slide, that PG role will create multiple schema versions before modifying anything on a physical structure of your table. So we have a table called users, which have 3 columns, ID, age, and full name. So as I mentioned, it will start creating an older version of view. So we can see the older version of view based on your original schema structure. Now we are going to perform 3 schema change operation, rename the column full name to first name, adding a new column, which is a safe change, last name, and also applying the not null constraint on existing column, which is a risky change. Okay, so you can see that after successfully creation the older version of view, then it is going to be start applying all the changes on a physical structure. So you can see that the 2 columns are there, PG role, new age, because that is a risky change, so it's always, instead of modifying directly on an age column, it will create a new column in a background. And this is the safe change because it's a new column. also based on that, it is also create a new version of your view based on the final desired structure of your physical table. Once we are satisfied with all the changes, we are going to finalize those changes. After finalizing of the changes, the older version of view is going to be removed, and your physical schema structure is completely identical copy of your view. So now the question definitely comes in mind that, is it required any additional storage, or is it doing a duplication of the data as well? So answer is no. It's just focusing on the metadata and just handling the the DDL structure. So there is no additional duplication of your data and no additional storage is required. Again, another question is like how DML operation is going to handle during this period of a time. So PG role is a very smart enough to accommodate your all the DML operations during this particular period by using the combination of your triggers, transaction tracking, shadow tables, and metadata mapping. So using all of the combination of this, it will ensure that your all the DML transactions are going to be addressed successfully. So now the part of installation process. So like any other software, PG role also have basic requirements, which is like, it's written in a Go language. So Go language is a primary requirement. So it has to be version 1.23 or later version, and to install directly from the source code. So you can execute this particular command. So we will get a latest version of the PG role installation successfully done. After successful installation, your PG role binary is going to be stored inside the root Go bin. And if you are okay to modify your environment variable, or also you're okay to provide the full path of your binary, then you can continue. But if you are lazy like me, you don't want to use a full path and all the stuff, so always the optional step you can follow. You can copy PG role binary inside the USR bin. So it will be easy to, without any modification, you can easily utilize that. Okay, so another requirement after the software is installed, another requirement as a last step for successful installation of PG role, we have to initialize the PG role to create the necessary metadata information, to store the necessary metadata information. So for that, table and functions are required. So if you have a SSL setup already configured in your PostgreSQL, so you can able to utilize the first command. And if you do not have SSL in place in your PostgreSQL, so you can utilize the do SSL setup command. So you can see the almost similar is, both the command almost similar. The last one also have a SSL mode is equal disable option you need to add when you are dealing with the no SSL configuration. So in my test environment, I'm using the Fujitsu Enterprise Postgres 17, and test_pg role is my database, and I don't have a SSL in place at the time, so I'm using the no SSL command. So after successful execution of the init command, we can see the initializations completed successfully, and a new schema, PG role, is going to be created. And the new table also going to be created called the migrations inside the PG role schema. So, so let's understand. So this is the last step for your final configuration, or I would say the installation of your PG role. So now you can see, let's understand how we can use those things. So PG role will accept all the input file, or I would say the change file, in a JSON format only. So we have to create a JSON format. And if you, in this presentation, I have kept all this example very simple, but if you would like to get more idea about that, how it works in a complicated scenarios and all the stuff, so I would request you to visit this particular link on a GitHub. Over there, you will see 40+ examples. Over there, you will get a complete opportunity to get your hands dirty with the PG role. So here you can see on the screen that I have created a JSON file, which is responsible to create a new table called users with the 3 particular column: ID, username, and email. And ID is going to be on my primary key index, primary key constraint as well. So this is my change file. So once it is done, so our responsibility is to execute the schema change with the help of start command. So when we execute a start command, so start command will immediately initiate the schema change process in a background by creating the virtual schema, and also start applying all the schema change which is mentioned inside the input change file, and also without affecting the existing one. So you can see on a screen that I also give the virtual schema name public 01 create user table. So this is the virtual schemas created by PG role, and all the modifications, or I would say the change, is going to be created inside that virtual schema. Simultaneously, when we are going to query the migration table, we can see the record for our first, adding the table migration activity, or I would say schema change activity. We can also able to see the status with the status command. You can see when we execute the status, we can see the status in progress. And once we execute the complete command, so I have to mention that when we execute a complete command, then there is no possibility of rolling back those applied changes. Because when we execute a complete command, it will finalize the changes by removing the older version of views, which is already removed, so there is no possibility to rolling back to the older version of view. Also removing all the temporary objects, as well as also remapping your metadata with the database objects. Next one is the adding the column inside the existing table. So I'm going to add a 2-column salary and designation, and I'm going to use not null constraint for salary column, as well as default value is 5,000 for the salary column. So this is my change file to accommodate this change. Again, same command, I need to use a start, status, and you can see that when I'm going to describe that particular table, 2 columns are with the temporary name is already mentioned inside my user table. So, and after the successful complete command, you can see that all the temporary names is going to be renamed according to the desired output name, which is salary and designation. Now the last use of adding the index. So I'm going to create an index on a salary column. Index name is going to be IDX salary column. Same thing, same steps are there going to be performed. We have to call the start name and passing the input file. But now you can see here, my index is already added inside that. But after that, I'm not happy with this change. I thought let me revert back this change. So how we are going to do that? Because I never execute a complete command. So I have a still possibility and privilege to rolling back applied changes. So I need to execute a rollback command. So when I executing the rollback command, so immediately it will redirect my database to the older version of schema because it's still available, as well as it will start removing all the changes. I was discarding all the applied changes according to the input file, as well as remove the new version of your schema. So now you can see that after that, PG role, the older index is still there, but newly salary column index is automatically removed. And after successfully execution of rollback, my migration status is also going to be complete. So I don't need to execute a complete command. Okay, so now the comparison with the other tools. So as I walk you through that, PG role is offering a lot of features like allowing all the schema changes without downtime, as well as also have a backfilling data capability, instant rollback capabilities as well. So this particular features makes, the PG role is one of the shining star if we're comparing with the other tools. And nowadays, most of the enterprise customers are always worried about the unnecessary, I would say always focus on reducing the, service disruption for this kind of schema change, because schema change is also very important, which helps us to cope up your application with the cope up with the high demand day-to-day requirements. So we cannot stop those things, but with the help of that, we can address those concerns raised by the enterprise customers, and with the help of that, they can reduce the amount of downtime. If I'm comparing with the other tools like Liquibase, Flyway, so they are very good tool for applying the schema changes, as well as also allows to tracking down those changes as well, and possible to integrate with the CI/CD pipeline. But by default, it is not available, possible to achieve the zero downtime. And also, we need a lot of manual efforts required to achieve the somewhat level zero downtime capability in Flyway and Liquibase. While the other hand, schema change is specially designed for the Snowflake database migration, and there is no possibility to achieve the zero downtime because there is no focus on that to achieve in near future as well. Last one, I'm sure everyone is fully aware about this tool. So there is no introduction is required to this tool as well. So this tool is specially designed for interacting, it's a database management tool, and it's especially designed to interact with all the database objects, like for the querying the data and all those stuff. So anyhow, we are still able to apply the schema changes, but again, it's require a downtime. So there is no possibility, and we cannot consider as this particular tool as like what PG role is offering all the features. So that's clearly indicate that PG role is one of the shining star for achieving the schema changes without downtime. Yeah, so that's from my end. I'm open for the question. I hope we have time.
Right, thank you for that. Pass it around for some questions. We got about 5 minutes or more, I think.
Thank you very much for introducing this tool. Looks really interesting. I have two questions. First of all, I quickly checked the documentation, and it says we need to provide basically the JSON files for each kind of migration. My question is basically usually for people who used to use Flyway and other tools, how good is this tool in determining the raw SQL? Or for raw SQL commands basically in the JSON, it would be the same as in Flyway, no guarantees on complete, and basically if it ran, it ran. And does it provide any kind of zero downtime guarantee for SQL as well?
Okay, so PG role will utilize your metadata details and also create the multiple shadow tables in a background, or I would say temporary tables to accommodate all the changes, to accommodate all the changes without any affecting the service disruption for which already ongoing at the time while you are applying the changes.
Okay, and the second question is I understand the reasoning behind all these commands like init, start, and complete, but does it have any kind of command just if I have 40 scripts and I want to initialize the fresh database, does it have any command for migrate 40 scripts from scratch and just create a DDL for me?
Okay, so you're talking about the migration in a mode of batching?
Yes.
No, as of now, there is no possibility at this moment, but maybe in the near future, you will get those batching, but yeah, as of now, you can able to accommodate all the schema change in a one JSON file. Then PG role will execute those things, but it will not allow us to pass the multiple files at the same time.
Okay. So basically, I will need some sort of bash file on top of it, right?
Yeah, something like that.
Okay, thank you.
Yeah.
Good. Further questions from the audience? Schema migrations, all that complexity. Yes?
From your completed stage, after you do your PG role complete, can you actually do a reverse of what was done?
Okay, so as I mentioned that after executing the complete command, there is no possibility to roll back with the help of PG role. After that, you have to be a traditional proper planning and proper analysis for rolling back those changes.
So you've got to rewrite the JSON file in reverse and then apply it?
Up to how you're going to so if it's a very minor change, you want to remove that. But so for example, you add a new column and you are not happy with that, you found some issues, you can also write another change to roll back. But it is already data is already going into that particular column. Maybe you have a foreign key referential integrity for that. Then you have to do a proper analysis to avoid any data inconsistency or data loss.
Okay, thank you.
Thank you.
Could you speak to the how mature the tool is, how battle tested it is, how many years it's been in service, who the active contributors are to this system? Is it Fujitsu itself, or Fujitsu just happens to use it a lot? Or
no, this tool is developed by Zeta. There's another organization based in Europe. So I'm just sharing those as an open source community. So I'm just sharing the information about that. So there is as of now, no contribution contributed from Fujitsu and for this particular tool. So just using, and it is newly introduced. So I thought it's a good platform to share those information about that.
Just to that, how many years has it been around, or who's kind of maintaining the roadmap of where this tool is developing further?
Entire product management, roadmap, decide everything done by the Zeta only. So, or maybe already available on a GitHub, so people can start, sharing those feedback, or maybe they have any bugs, so they will start, replying, fixing those bugs as well. So it's purely open source project as of now.
Mm-hmm. Maybe for the audience here who hasn't yet worked with this tool, are there any features or functionalities that you'd think are either still critical to add or things that you're aware on the roadmap?
There's definitely, this guy already arrives, right? We can apply the multiple batches as well. And also, like, I can say, like, as of now, only few commands are there, like complete and all the stuff. So I would say if verify supposed to be that, so at least we can see how it's going to behave as well before finalizing the changes as well. So like those are the things, definitely we can also add those functionality. But again, as I mentioned that it is newly introduced. So I think slowly, gradually, they are also taking all the feedbacks and going to, you know, develop the robust tool and addressing all the challenges.
Mm-hmm. Okay, that's a fair. Okay, any other questions? We do have a bit of time. Maybe
If no question, then I can ask one question and I can give the gift to the lucky one. Is it okay? I'm going to ask a very basic question. I'd already covered in the slide as well. So my question is like, what are the features offered by PG role? Can anyone name all the features in a one shot? I think it's not a tough question, I think.
Anybody? Okay.
Yeah, it's a lucky one.
I guess zero downtime migration and then like multiple distribution support. I mean, there were like 8 of them. So yeah, I think I can name only these 2 at the moment.
Okay. Apart from, okay, so 2 we have, anyone can able to remaining 6 or 4, I think it's not 8, but say remaining 1. If anyone can able to answer.
It's tricky because, you know, recall what you present there. So anybody else want to give it a try? So you're testing if the audience was listening.
This is the
right?
last guy.
So,
He wants to answer.
Zero downtime migration, instant rollback. And that's all I can recall.
oh, we have a tie. Okay, front row.
Non-interruptible, potentially can be rolled back schema migrations based on set of rules that are user-defined in JSON format. And you can also query status of your cluster. You can also roll back depending on it. You can monitor it. So I mean, you have quite a few keywords, and you've been also. Oh yeah, actually, I had a question on that. You did mention the use of a table you use to store the set of rows that have their changes applied. Didn't you get some inspiration from another extension called PG Repack to do that? Because it's been using statement level triggers to catch the changes and do so. So you've been using that at C level with the C level triggers to do so. I didn't look at your project, so it's not SQL based. It's not PL based. You've been using some internal C and shortcuts with in the internal APIs of Postgres to make sure that it's actually a little bit efficient, even if you have a batch of changes. Is that right?
That's completely true. But I was expecting the list of the features. You are talking about the internal, the working of.
But I also did mention a little bit of the features just earlier. So, non-interruptible migration changes based on set of inputs given by the user and customize. I mean, it's possible to customize also what you can do. So, I mean, you have a lot of keywords.
Yeah, I agree. Okay. There's another guy who's interested to answer.
I would go. No,
okay.
Written in Go.
Sorry?
Written in Go.
Huh?
Automatic, backfilling of the tables. Third is, obviously, online now, which is zero downtime. Yeah. Fourth is, what was that again? Yeah. So the online rollback that you have, automatic rollback in place, and works with any existing Postgres version starting from 14 onwards. Yeah, I would say that's the 5.
So that is a very close answer now. Hardly a couple of his mistakes.
Also, automatic column backfilling, was it there?
Yeah.
And no database locking.
Yeah, okay. Somewhat level, okay.
Yeah, that's what I think was missed.
So Nijay, you'll have to make a
So
call
I think
now as to who got.
Hari was the guy who answered almost all. I was only except two. So I think, okay, I'm going to, this is a lucky winner guy. So who always give a exact answer.
Okay. I think you'll have to maybe circle back to Michel about his question that he wove into his answering there earlier, but perhaps offline.
Samir and Runil from AWS, who can share about SQL Server to PostgreSQL migration. So please clap your hands and welcome the guys on stage. Thank you very much.
Thank you, everyone, and welcome to our session on managing backups, collation, and case sensitivity for SQL Server to Postgres migrations. My name is Ronil Kumar, and I'm a Senior Database Specialist Solutions Architect. I'm based in Sydney, Australia. I actually work across customers with from APJ.
Hey, hi everyone. Good morning. I'm Samir. I'm a database specialist, part of enterprise support organization in AWS. I'm based out of Singapore, and I work with some of our largest customers who are always pushing the boundaries of what is possible with a database. So today what we are going to do is we are going to talk about some of the nuances and challenges that people face and they come across when they're migrating their workload from SQL Server to PostgreSQL. Between me and Ronil, we have talked to at least about 100 SQL Server developers and database administrators in last year or two. And what we are going to try and do today is compress all those conversations in next 40 minutes. Quite a daunting task if you ask me, but we are going to try that nevertheless, and we'll see how that goes. We'll talk about architectural comparisons, then we'll talk about some of the interfacing with the database, like how do you insert data, how do you access data, and then we'll talk about some of the administrative tasks that you need to care about when you're moving over from one database to other database. To get started, I'd like to ask you, Ronil, you work with customers across APJ. Why do you think people are looking for alternatives? Why are businesses, enterprises looking for alternatives?
Yeah, excellent point, man. So basically, customers are looking to break free from the lock-in of punitive licensing and are looking to actually being able to go in and deploy in cloud-native environments if needed as well.
All right, and why do you think PostgreSQL is a good fit for them?
First of all, I would say licensing. I actually come personally from a commercial database background, and we always used to actually go in and think about the pain of actually the licensing to begin with. So with Postgres being open source, it actually brings with its the cost efficiency being open source and the community-led development. We actually had our colleague Michael Pecchia who actually was talking about AWS's commitment to the open source community as well. But Postgres in itself actually is, as I said, open source, community-led, and then the flexibility to deploy the database, where customers want it, and gives them the confidence that we won't be locked in, because Postgres, as you know, is owned by a community. It's not owned by any enterprise. And Postgres has many enterprise-ready features that it comes with, and it actually has a healthy subsystem of plugins and tooling around it.
Nice. So let's dive into it now, starting with some of the architectural comparisons. And what we'll get started with is the logical layout of how you structure your data and how it's structured inside the database. So in a SQL Server database, you would typically have an instance which has some special databases, or you can call them the base databases that are already there when you create the instance. MasterDB, TempDB, Model, MSDB, and then you can create a number of user databases. This is where you can store your data, and you can organize that data in basically multiple schemas, and then you have tables within these schemas. This is how you logically store data in SQL Server. How do you do that in Postgres?
So Postgres is also a relational database, so it's not much different. So when you initialize your instance, you get a few default databases. So basically your template databases, template 0 and template 1. So template 1 is very similar to your model database that you actually get within SQL Server. And the Postgres database that you see at the bottom is the default database that you'll get. It is no different than any other user database as well. And you can actually create one or more user databases, and within that schemas, and then logically organize your objects within it.
Right. So not a lot different than PostgreSQL. That's convenient for users to understand. All right. Let's talk about how that data is physically organized on the storage. So in SQL Server, you are going to have basically TempDB, that's a special database. We'll talk about some of its use cases later on. But inside a user database, you are going to have file groups. This is where actual table and index data lives, and then transaction logs. We'll talk about how transaction logs are used for writes, but this is how data is physically organized in SQL Server, on a very high level. How does this happen in PostgreSQL? Is this also similar in Postgres?
Yeah, cool. So Postgres, in that respect, is slightly different, but it is very simple to understand. So databases are more of a logical construct. So if you actually look at the physical directory, you'll actually see that how simple and intuitive it is. So inside the data directory, you'll actually see what's called the base directory, and in it, it'll actually have each of the databases that's are created within that instance, and these are actually represented by basically database OIDs that you actually see here. And inside the databases, you'll actually see multiple files, where each file actually belongs to a particular object within the database, and these are actually created in 1 gig chunks. So as soon as it actually reaches a 1 gig size, Postgres automatically will actually create another file for it. And what it also will have is the well directory, right? So pgwell basically means your write-ahead logs, which is equivalent to your log files within SQL Server. And they're actually stored in what's called pgwell. And it actually has the, you can actually go in and create them on a separate storage as well, similar to what you usually configure within SQL Server as well.
Right, but no concept of a data container or sort of file groups what we have in SQL Server.
So Postgres has what's called table spaces. So you can actually go in and store data on another storage volume. So that's basically where you'll actually have a table space directory inside the base, and you'll actually have your databases within that'll actually exist in separate physical volumes then.
Okay, I guess I have got to agree with you. It's quite simple and intuitive. You have got data inside that database, and then quite neat organization. Great, let's go to the next concept, that is read caching. Let me talk about how things work in SQL Server on a high level. If you make a user connection and you select something from from the database, if the pages required to serve that query are not in the cache, they'll be first read from the cache and then used to respond back to the user query. And as you make more queries that have to deal with rows on the same page, they are going to benefit from the page being in the cache. This is a great performance improvement. How does this happen in PostgreSQL?
Yeah, so more or less, it's basically the same in SQL, in Postgres as well compared to SQL Server. But there are some differences in the way I/O is actually performed, but the concepts are pretty similar.
Right. Okay. Now let's talk about writes. In SQL Server, typically what's going to happen is if I have a buffer cache in the memory, let's assume that it's already there in the memory. If not, during an update, I'm probably going to read it from the disk first. As I do the update, it gets dirty. And when I do a commit, that's when it gets written to the transaction logs. And then I can have multiple transactions hitting the same page or multiple other pages, all of them getting dirty, and they get written to the transaction logs as I commit those transactions. Once in a while, there'll be a checkpoint, and that's when those dirty buffers will be written to the storage, basically your data file, or where data sits in terms of file groups. And these transaction logs can be backed up, which is where, which is what I can use for point-in-time recovery or log shipping replication. How does this work in case of PostgreSQL?
Right, so Postgres has something that's very similar. And again, there is differences in the way Postgres does or performs the I/O, but more or less, it's the approach kind of is the same in Postgres as well. The same concepts of it actually reading from going to memory and then basically going to the data file if it doesn't exist in memory, and then if it doesn't exist rather in memory, it actually goes to the file system to get the file, stores it in memory, and then basically returns the results to the client.
Right. So quite similar concepts like checkpoints and wall archival and those things. All right. Okay. Now, so we talked about the archival of the WAL files, and I mentioned point-in-time recovery. In SQL Server, we have some sort of a concept called recovery model. Can you help compare the recovery model in SQL Server and the equivalent features in PostgreSQL?
Yeah, so by default, Postgres has the WAL settings to minimal, which basically is the equivalent to what we call it a simple recovery model in SQL Server. And it actually means that the WAL files can simply be used for crash recovery in that case. The next we actually have is what's called full recovery model. So in Postgres, that equates to what we call as replica. And this setup actually allows you to set up replication for lock shipping to another instance, as well as being able to do point-in-time recovery as well. The third concept that SQL Server has is called as a bulk recovery model. Now, bulk recovery actually gives you performance if you're actually doing bulk loads. Postgres, if you actually look at it, doesn't have an equivalent level to actually that's actually there as well. But we can actually achieve a similar optimization by using synchronous commit to off. In that case, so whilst you're doing the bulk loads, the other method that's actually there is if you actually are using change tracking in SQL Server, it allows you to do change data capture and set up heterogeneous replication, which you can, if you're doing heterogeneous replication, you can achieve that by setting the WAL level to logical in Postgres as well.
Right. Now let's talk a little bit about the memory architecture. So in an instance in SQL Server, you can reserve memory. You can set a parameter that sets the maximum amount of memory that the instance can take, and it can grow and shrink as your workload changes. And the most important component in there is buffer pool. We have talked about how this buffer pool is used for caching, the buffer cache. And this is where data gets cached. And there are other components as well, like log buffers, plan cache, lock manager, and they are shared structures. They are used across all the connections. And then there are per process or per connection allocations in terms of query execution memory or index creation memory. That is how it works in SQL Server. Ronil, can you talk about how PostgreSQL uses the available memory?
Sure. So Postgres has a very similar architecture as well. So Postgres actually also has shared memory. As you know, shared memory caching is going to be common to across any relational database, which is basically a kind of like a fixed allocation that you get for buffer cache, which is used for caching. But the key difference here is Postgres will also have per connection buffers as well as the ability to actually have file system caching, which basically relies, on the file system for your IO operations is there. So basically means if you're actually reading or have data or data files that actually are going to disk, it's able to actually cache it at the kernel level as well. And on Postgres, you typically leave about 50 to 70% of your available memory for your system caching as well. And as I said earlier, there's other shared memory structures for process allocation on the Postgres server. And one important thing to remember is Postgres also actually maintains, your execution as well as metadata execution plans in the respective cache areas as well.
That sounds like a bit of a mind shift change for users when they go from SQL Server to Postgres. It seems like they should reserve good amount of memory for file system caching. Would you say that?
I would say so, and that's primarily because of the underlying architecture of Postgres.
Okay, cool, nice. Okay, thanks. All right, let's talk about TempDB. I said we'll talk about this special database a little bit. TempDB is used, one of the things that it serves is if you are using temporary tables, and if they can't fit inside the memory allocated for caching them, they spill over, and that they get written to TempDB. Second thing they are used for is sorting, any kind of sorting operation. You want to get people who are paid the most. You want to get people sorted by their joining date. If you want to do these kind of operations and it can't fit inside the allocated memory, it starts spilling over to the disk, which is basically in TempDB. It also serves another purpose where it is used for storing old version of the rows, and that is critical when it comes to multiple versioning and concurrency control. We'll talk about that in a bit of, I think, in the next couple of slides. But as you can see, there are a few things that are happening in TempDB. And when I used to work with SQL Server back in the days, one of the things where we used to face contention was on the TempDB and the files, underlying files of TempDB. Is that something users have to worry about with Postgres as well?
Yeah, cool. So this is one of the other things that I actually potentially will say I actually love about Postgres. So Postgres actually stores your temporary objects in your temporary table space, and you can designate any of your user table spaces to handle temporary objects as well. But Postgres will use what's called temp buffers to cache temporary tables and then write them to your temporary files. But sorting happens primarily or first in a memory area known as workmem. And your maintenance tasks, so things like your create index or reindex operations, will use the maintenance workmem memory area. And if the memory is not enough, it'll end up, Postgres will end up writing to your temporary file system on disk as well.
And what about the cleanup?
So the cleanup will actually happen as soon as the user connection closes. Your temporary files that actually get created on the underlying OS will get automatically cleaned up as well.
Oh, that's very convenient. I don't have to worry about expanding the file group or cleaning up these tables. That's easy. That's convenient. All right. Now let's talk about the multi-versioning and how that affects the isolation and concurrency. So in SQL Server, when I am writing something to a row, let's say I'm updating or if I'm deleting, until I have committed, I can't do any read on that same row. And how does that work in PostgreSQL?
Yeah, so in Postgres, when we actually look at options, things like your no-lock options, these are things that don't need to worry about in a Postgres database, and that's primarily because readers don't block writers. And the default behavior, and that's the default behavior as well. And you can't actually even go in and change that as well in Postgres.
Nice. You said something interesting because that's one of the top conversations I get engaged into when we talk to a SQL Server DBA. They ask, hey, do you have a no-lock option? And I say something similar to what you said. You don't need it because readers don't block writers, writers don't block readers. That's very neat in Postgres. All right, actually that is also possible in SQL Server when you use snapshot isolation. And in that case, what SQL Server does is whatever writes are happening, whatever rows are getting modified, or if you're deleting something, the old versions get stored into TempDB, and these old versions can be referred by a select query or a read query that may need to refer to them. Is this what happens in Postgres as well?
So Postgres, that's one of the things that's very different in a Postgres database. So if you're actually familiar with Oracle and your dreaded, snapshot to old era, that's something that you won't see in a Postgres database. And that's because, updates per se are never in place. So it's if you actually go in and do an update, it actually is a soft delete and then a new insert. And deletes similarly, don't physically remove the rows from the tables itself. And the old row versions are left in place, and updates always actually goes in and creates a new version, as I said earlier, which basically means that a select query can work with one of the row versions depending on when it actually started, and that's the underlying architecture of MBCC within Postgres as well.
Right, okay. So let's see how does that affect isolation level. Now there is a lot on this slide. What are a couple of things that you want to call out and highlight on this slide?
I guess the kind of things that I probably want to highlight is both of these databases support the 4 ANSI isolation levels of read committed, read uncommitted, repeatable read, and serializable. Even though the snapshot isolation level is not there in Postgres, but the behavior is similar to read committed or very close to that. And one important factor to remember is that Postgres, you'll never be able to read uncommitted data, and you will never see reader-writer conflict within Postgres as well.
Oh, that's nice to build concurrent applications. All right, let's now talk about some of the developer features and how some of these features like accessing data or storing data, how they compare between these two engines. All right. So yeah, Ronil, go ahead. Talk about how you would store numbers.
Yeah, so to begin with, like if you actually store decimal values within the Postgres database where accuracy matters, for example, if you're actually storing interest rate or foreign exchange data, you can actually migrate that using what's called numeric data types within Postgres.
What about integers? Can I use numeric for them as well?
Yeah, so numeric is actually meant for precision. So, for numeric, for integer data, I'd rather use integer or big int depending on the size of the data.
Right. What about scenarios where I'm happy to have a trade-off for better performance? So I'm happy to let go of accuracy in favor of performance. In SQL Server, I can use real or float.
Yeah, so in Postgres, I'd actually use what's called double precision, or in short, double in Postgres.
Okay. And then what about bit data type? Developers use that to store things like, hey, did Samir attend this conference or not? Or was this delivery made or not? So status kind of things. How would you map that to PostgreSQL?
Yeah, that's something that's actually slightly different within a Postgres database. So Postgres doesn't support bit as such. It actually has data type known as bit string. But based on the use case that you just described, in Postgres, I'd rather use the Boolean data type. That's one of the things, though, it actually allows you to store either true or false compared to a 0 or a 1 or a T or a F in using bit in SQL Server. But, this is one of those scenarios where you need to do a data conversion when actually moving to Postgres as well.
Okay, so there is a bit of effort involved there, right? Okay. What about string values? How would you store strings in PostgreSQL as compared to SQL Server?
Yeah, so Postgres supports what's called variable and fixed length strings, your varchar, your char data types. And you can also have strong, large text objects like, if you actually are storing an article or this whole presentation within, you can use your text data type for that as well.
Right, okay. And is text like a CLOB data type or what is text like?
Yeah, so text, think of it as a LOB data type, I would say. I mean, like for large objects, I would say very large text objects, it'll end up being a LOB data type there.
Okay. Okay. All right. What about nvarchar? I store Unicode characters, like somebody's name in native Thai language or some other Asian languages. If I'm storing that in my database, how would you do that in PostgreSQL? Is there nvarchar?
Yeah. So that I think the Postgres doesn't have what's called nvarchar, but you can still use varchar data types for that. So character accept whatever that you're using will be supported, based on the encoding you use at the time of the creation of the database.
All right. So I don't need to worry about it separately. Okay.
Yeah.
Got it. What about dates and times? How do I migrate date or date time or time data types over to PostgreSQL?
I would say dates are easy. So Postgres has what's called a date data time, and so is time. And for time data type, we actually have what's called a date time data type within the Postgres data type, and you can also use what's called timestamp in Postgres.
You mentioned timestamp for date time, but there is a different timestamp data type in SQL Server, and that is deprecated. People now mostly use row version. So how does that become date time in PostgreSQL?
Yeah, that can be confusing, but that is very different within Postgres. So, it's different to the Postgres timestamp data type. And timestamp with time zone is also used to store date and time, similar to date time and date time offset types that you actually use in SQL Server.
Got it. So it has nothing to do with the date time timestamp data type of SQL Server, which is binary sort of data type. Okay, got it. Okay. All right. What about binary data? Because sometimes people use that to store, text files like this presentation in PDF format or receipts. prescriptions. So I can use binary or var binary. Some legacy applications in SQL Server also use image data type. How do I migrate them to PostgreSQL?
Yeah, that is simpler in Postgres. You can simply use what's called the byte data type within Postgres to actually store your binary data within Postgres as well.
Got it. Okay.
Ahmed, like, given your strong background that you actually have come from with NoSQL and unstructured data, how do you actually go in and think about storing that within a Postgres database, so your unstructured data?
Right. So PostgreSQL has purpose-built data types like XML to store XML values. You can also store JSON data, and not just you can store these data types. You can also query them. You can parse them, and you can even update JSON data. There are JSON operators, XML functions, JSON functions that allows you to operate and deal with that data.
Nice. So what about your geospatial data type?
All right. The geospatial data types. Let's pivot a bit. Let me talk about a different concept. Postgres has this neat concept called extensions. And it does what it sounds like. It extends the capability that are not available in the core. And there are some extensions available which adds new data types and operators, functions that you can use with those data types. Even index access methods that allows you to index those special data types. And one of them is PostGIS. And what PostGIS do is allow you to store location data, like the location of this conference, or the layout of this hall, where points are, as in where chairs are. All this kind of information you can store inside with purpose-built data types that are provided by PostGIS. And it's one of the most popular extensions,
Nice. So what are some of the other cool extensions that you can, highlight to our room that's going to be important in Postgres?
One I can talk about is PG Vector. It's another popular data type that's out there. It's relatively new as compared to PostGIS, but it's getting a lot popular. It allows you to store vectorized information. So if you have vector embeddings and you want to store them, index them, query them, you can do that with PG Vector.
Awesome. So what about managing your auto-incrementing sequences or your auto-assigned unique identifiers?
Right. You can use serial data type, which basically uses a sequence underneath, or you can use generated always as identity columns, and you can specify the incremental steps or starting step. And when you use these columns or these designated definition against the column, what happens is as you insert rows, these rows are the column value is auto-generated. Another option for you is to use UUID SSP extension, which adds UUID data type, and then as you insert values, they generate UUID with a bit of randomness in it. That helps avoid any kind of contention on the sequences. All right. Let's now talk about sorting and collation for a bit. Let me talk about SQL Server first. SQL Server supports case-insensitive and accent-insensitive collations, which is helpful when you need to search for a value and you don't know how was that value initially stored in the database. From practical use case perspective, back in the days when I was dealing with banking and anti-money laundering applications, this used to be extremely helpful for dedupe checks or checking for a user when I don't know how exactly their name was stored. And as you can see, based on the collation, I would get the data out from the database with my select query, irrespective of what case I use in my where clause. Now, one of the things with collation in SQL Server is it is not just about the data. Your metadata also follows the same collation. That means if I have a table called person and I use case-sensitive collation, when I query that table with capital case, it's going to fail. So I have to be very careful in what case I specify even in my queries. What about Postgres? Can you talk a bit about Postgres?
Yeah, cool. So in Postgres, all metadata by default is stored in lowercase. And even the query processor will actually convert all of your identifiers, like your table names, your column names, to lowercase. And then, when you use query that uses mixed case or capital case, in that case, it will work fine. Unless you go in and code the identifier, and you can code the identifiers if you actually use, if you want to preserve the case of the identifiers in that case. And it is a good practice, so to speak, in Postgres to actually avoid mixed case or what's called camel case when you're actually naming tables or columns. And if you want to have tables with the same name for, for example, different modules, if you've got accounting schema, in your HR schema, if you actually want to put, an employee table that exists in both those schemas, both those applications rather, you can put them in schemas to actually differentiate the tables in that respect.
Got it. What about handling case-insensitive search in Postgres?
Yeah, you can use what's called the lower function, which works great, but you can also use what's called the like operator within Postgres as well. But if you're migrating from SQL Server to Postgres, changing code can be a lot of effort in that respect. And an option to actually reduce the migration effort is to use the CI text extension that adds the CI text data type within Postgres, and all the string operations in that case become case insensitive like SQL Server. So you can also go in and index your CI text columns, and you can also choose your data to be case insensitive by setting your database collation at the time of creation of the database. And now with the addition of the ICU collation, it is much simpler. So it actually goes in and adds the capability to simply create or specify the collation, and you're actually able to use that sorted as well as the character classification behavior at the column level without having to recreate the database.
Right. Let's quickly talk about accessing data. I know we are running short on time. All right. In SQL Server, let's talk about authentication and authorization very quickly. You got a super user. You first connect using that super user, which will basically go ahead and then create a new login. Then you have got to create a user for that login in specific databases that it should be accessing. That basically controls what databases it can access. And then at the table and schema level, you can specify specific grants. So you control what schema and what specific tables this user can access. How does this work in PostgreSQL?
Yeah, so Postgres is slightly different. There is no separation of users and logins. So roles that can log into a database are basically called users. And similar to our previous SQL Server steps that we actually saw earlier, when you connect to our database, we connect to the Postgres database. And on the Postgres port as well. But you also specify the database name, which is why when you create your database instance, you actually get the Postgres database by default. So once you actually have your connections created, you actually go in and create a user with your appropriate password, grant your permissions to the user to connect to one of those one or more user databases that's there. Then you actually go in and grant your appropriate permissions on the schemas, and then the permissions on the respective objects that you will actually have. And if you actually have multiple databases, obviously you actually need to go in and repeat those steps across all those databases as well.
All right. Let's talk about data access and federation. So if you've got a table inside a database, you connect to that database, select star from that table. You can use schema or table name, and that will give you access to that table. If you want to access data in a table that is in a different database within the same instance, you can use this three-part name, which is database.schema.table name. You can also use linked servers. These linked servers allow you to access data in another SQL Server database, or even other heterogeneous databases like MySQL, Oracle, and then you can query them. How does this work in PostgreSQL?
Cool. So in Postgres, you can connect to your instance by specifying a a database name rather, and then you actually go in and run your select queries on it. But the Postgres database is a lot more stricter in that aspect of, you won't be able to make a cross-database query on that same instance as well, the way you described, by using a three-part name in SQL Server. So if you actually want to use or connect to a separate or different database from the one that you're connected to, you'll need to actually establish a new connection using what's called a foreign data wrapper. And you basically, a foreign data wrapper allows Postgres to interact with other external databases as well, other relational databases like SQL Server, MySQL, Oracle, and Postgres as well. And properly configuring your foreign data wrappers enables seamless data access without having to migrate the data and making it an ideal solution for hybrid environments as well. And you need to set up the foreign data wrapper server as well as the foreign table for you to actually be able to make that query to actually access the table as well.
Okay. All right. Now, quickly talking about the access methods, PostgreSQL is SQL compliant, right?
Yeah. So Postgres is a SQL compliant database, and most of the query patterns that you'll be using is SQL Server that you use are actually available on Postgres as well. And the catalog for functions for your string operations, for your type conversions may differ, but you also need to rewrite your TSQL code to something like PGSQL or your stored procedures as well.
Right, so that means there may still be some effort involved in migration, even though the syntax is similar, it is not exactly the same, right?
Yes and no. We actually launched what's called a Babelfish extension that allows, in your migration complexity and being able to migrate your TSQL code to Postgres a lot more easier. We'll talk about Babelfish slightly later.
Right.
So.
Okay. Let's talk about some of the administrative tasks. Starting with backup, in a SQL Server instance, you can use Management Studio to generate a logical backup, which is basically a create script that is portable. You can also take physical backups, which can be full or incremental, and then you can set up log archival, which then works for point-in-time recovery. Can you talk about backup options in Postgres?
So Postgres supports logical backups using what's called pgdump, allows you to actually dump your data, and it is portable through versions and supports multiple formats as well. And you can actually go in and do full backup with what's called pg-based backup. It is a physical backup tool in Postgres that allows you to create the binary copy of the entire database cluster, including your data files, well segments, and configurations. And with Postgres 17 now, it allows you to use incremental backups in using PG-based backup, which is basically similar to your differential backups in SQL Server.
Got it.
And you can use your archive logs to basically go in and do change data capture or point-in-time recovery within the database as well.
Okay. All right.
And in Postgres, you also get the concept of, as I talked about, foreign data wrapper. So if you actually want to access external data files using CSV, or you can actually also use copy commands to load data, or PG loader for bulk loading of data within the Postgres database as well.
All right. And I think replication-wise, all the different replication topologies of SQL Server are also supported in Postgres, right? Log shipping, change data capture, and even always-on sort of architectures are possible. Is that right?
Yeah, absolutely. I mean, there's a lot on this slide, but yeah, just to summarize, you'll actually get, almost equivalent replication features. You'll actually have things like if you use transactional replication, you can use logical replication and all within Postgres as well.
Okay. Cool. All right. I'll quickly go to the next slide, which is on maintenance. And
yeah. So if you look at things here, SQL Server and Postgres both have different administrative models. So tasks such as your database monitoring, indexing, and monitoring need to be adjusted when you're actually migrating from SQL Server to Postgres. And Samir, one of the important things in Postgres is vacuuming. So would you want to actually just quickly highlight the concept of vacuuming in Postgres?
Right. So this is something that might be new for people coming over from other databases. Something that is not new is updating statistics. Every database needs to work with statistics. That's how planners work. But what's unique in Postgres is because how Postgres creates multiple versions whenever you update. Because of that, because of maintenance of those multiple versions, you need to clean them up at some point in time. And that's what vacuuming does. These multiple versions, the way they are versioned is using transaction ID. So as you create more versions, you are exhausting more and more transaction IDs, and you need to clean them up as well at some point. So auto vacuum does that as well for you. All these things can also be done manually. So you could also run them as a manual task, but ideal would be to tune auto vacuum settings and maybe schedule these vacuum tasks for once in a while. That's something very important for people coming over from SQL Server. From monitoring wise, do you want to quickly cover that?
I think we can, just in the interest of time, I think we can see there's equivalent of DMV functions that we actually have in SQL Server, and we can actually use those in Postgres as well. Things like your wait events, your logs, your database queries, you can actually use similar DMV functions in Postgres as well.
Right. Now, that we have covered most of the administrative tasks, do you want to touch upon the migration approach quickly?
Yeah, sure. So if we actually look at the migration approaches, we can use the first step of actually doing a database migration is basically your schema conversion, which involves migrating your database objects. Next, you'll actually go in and do your data migration, which involves, you either using a data export import or using change data capture, as we talked about earlier, using archive logs to reduce downtime as well. And the next phase will be actually one of the most critical, where you need to ensure that your Postgres database behaves, or application behaves the same as what it did in SQL Server in terms of your functional testing, and then you'll actually do your performance testing. So your Postgres database should actually be able to at least be able to perform at the level what SQL Server was doing on Postgres, or you need to do some sort of retuning, some sort of query rewriting to ensure that your database performs the best as well. And once you've actually done, you can actually go through with your cutover steps.
Now, let's talk about tooling available, and there are a lot of tools and things that are available to you when you want to migrate as an administrator. Is there a particular plugin or a tool that you want to call out from this slide, Ronil?
Yeah, so these connectors tools, that's actually there. One of the common tools that we use at AWS is Babelfish. Babelfish, as I mentioned, is a migration accelerator tool that AWS launched. It is available as an extension to open source Postgres as well, and it allows the Postgres database to basically be multilingual. So it understands both SQL Server as well as Postgres at the wire level.
Nice. With that, we kind of wrap up our presentation. If you're keen to explore PostgreSQL as an alternative to your workloads on SQL Server, go ahead, use these resources. There is documentation, there is help that you can get from mailing groups on PostgreSQL, and you can try out Postgres on Amazon RDS free tier. Thanks, everyone. I think we are at time.
We're going to have time for one question quickly.
All right,
so
cool.
this gentleman here would like to ask a question.
Samir, you touched upon the heterogeneous logical decoding. So
Right.
What did you have in mind from a replication standpoint?
Right. So in SQL Server, people typically use change tracking, and with SSIS, they can do heterogeneous replication topologies, which means basically SQL Server replicating to other databases. Some people also use federation, and they use linked servers when they want to access data on other databases or other data storage. In PostgreSQL, what you can do is logical decoding, and you can replicate data into Kafka or another PostgreSQL database, or even something else altogether, which is not a data store that you're typically familiar with. You can do all of that by using logical decoding in PostgreSQL. You can also use foreign data wrappers, which allows you to set up federation. And this is typically important these days because very rarely data sits in silos. You're going to have data that is connected to other data stores and other patterns. Sorry, you had a point, Michael?
So you didn't mention in your talk anything about encodings. Is there any kind of difference that users have to go through when it comes to a specific encoding that your MySQL, that the SQL Server is using when they migrate to PostgreSQL, or they just use UTF-8 usually? Do you have any comments of pain points that people know that could be even made better in Postgres when it comes to that?
Right. We touched upon that a little bit. In SQL Server, there is a data type called nvarchar that typically users use to store UTF or Unicode characters. In Postgres, you want to make that decision when you're creating the database by choosing the right encoding and the character set that you want to use. And remember, it's a one-time decision, so you can't go back on that. So ideally, it's better to use UTF or something that is more generally encompassing of different character sets that you're going to have to deal with. Yeah, that's a good point.
Great, I think we're up for time. So Samir, Ronil, thank you very much for that deep dive into
A big round of applause to Samir and Runil, everyone. Thank you very much.
Is on already? Oh, you can take from there. I'll get to switch slides. The clicker. Okay. Welcome everybody. Sit down and still coming into the room. Join us. We are doing the PG Day Postgres track, and we're just good on time. So that's great. We're now at 11:30, and I'm going to have a 40-minute presentation, I believe. Yes, by Vladan Popolitov, if I got that right. So he works in the Laboratory of Advanced Development and Research, and his research focuses on vector indexes and vector databases, also a hot topic in the whole conversations around AI and Gen AI systems. So I'll hand it over to Vladan. If we can give him a round of applause, please.
Hello, Sawadika, Ni hao, bonjour. Vector databases gained significant popularity in the recent years and became very popular in 2023. On this chart you can see ANNbenchmark.com results in 2023, and Postgres with PG Vector showed in the bottom line. It is slowest in the terms of queries per rate. By 2024, situation dramatically changed. Timescale DB published own benchmark. Authors used datasets with 50 million vectors, 700 dimensions, and as you can see, Postgres is 16 times faster and cost is by 75% lower. Now it's quite easy to change or to measure cost because we can buy service from cloud providers and can easily calculate cost. In 2025, VectorCourt.ai did benchmark for their extensions. They used dataset line with 100 million vectors, and the purpose of this benchmark was to demonstrate the showcase of linear scalability and performance reaching 10,000 query per second, increasing number of workers on the server with 2 replicas and with 100 CPUs and 1 terabyte memory. They used this server from Amazon cloud. And they use algorithm based on inf, and they use bit quantization. For those of you who are unfamiliar with vector, it's a brief introductions to vector. The growing use of vectors started from development and implemented word vectors by programs Word2Vec and GLAV. GLAV means global vector. They represented vectors for words, and these vectors is a list of coordinates in n-dimensional space, and vectors can be manipulated, such as added, subtracted. Since 2017, with rise of transformers models, applications started to calculate vectors for any types of data, not only for text, for images, audio, video, for sequences like data from sensors, air pressure, temperature, earthquake detectors, and now vectors used in many applications like anomaly detection, fraud detection, log files analysis, a lot of application. First important property of the vectors, vectors group concepts and meaning to similar clusters. For example, if we are talking about tower, word for word tower will be located in this vector space near the vectors of word building or skyscraper. Similarly, if we look at substances, for example, hydrogen, oxygen, metals, steel, or cities like Moscow, Bangkok, Tokyo, they would be clustered according to their meaning. And the second properties of vector, it was discovered later. Direction in the vector space corresponds to some meaning or concept. Let's take 2 words, man and woman, and find difference, this green vector. If we apply this difference to the word such as king, resulting vector will be near vector for word queen. It's not exactly the same because word queen has a lot of meaning. It's not only wife of a king. It can be name of chess piece king or musical band king, but it's in near location. Similarly, if we take word son and apply this vector, it will be near to the word daughter. It means that this green vector, it corresponds to the concept of gender. It's why vector so powerful. Vector can efficiently encode concepts and meanings as a mathematical objects. For example, concept, I show by my hand, concept animal, concept color brown, concept jumps, concept quick, and it's similar to vector Fox. It's not exactly, but how it works. Why vector so powerful, we can use in many applications. And the more dimensions we have in this space, the more concept we can encode. And in the same time, the harder for computer to process, why we have a lot to do with them. I should mention pgvector is one of the mature extensions. It has two algorithms. First, in flat, it's simple, and HNSW, universal algorithm. It's used in many applications. I describe it in next slide. HNSW, it has first parameter is m, number of neighbors for every vector. It's a graph-based algorithm, and graph means that every vector has neighbors. During index creation, every object added to the index and placed to the layer. The more number of the layer, the less object on this layer. Its quantity decreased exponentially and power the same number m. For example, if we have data set 1 million vectors, on the zero level we have all million vectors, while on the first level will be 20 times less, in our example 20 I took, it will be 50,000. On the second level, 20 times less than on the first level, and so on. And entry point of this graph structure will be always on the highest level. When we start search, we always start from the entry point, taking all neighbors and identifying vector nearest to the lookup vector. We, from this point, trying to find numbers of all of these lookup vectors. When we found nearest nectar, nearest neighbor, we go to the lower level. It has 20 times more vector, and we continue this process and find nearest vector, and so on. We go step by step to the lowest vector, and here we already approached in the neighborhood of our lookup vector. It means highest level help to solve problem of big and fast steps, while lowest levels solve problem of small and precise steps. It's why this algorithm is so powerful. And when we have to stop this search, it's a chart of tried neighbors with distance, with measured distance. When we continue the search, we found local minimums during the search and count number of neighbors in every minimum. We have second parameter, EF. For example, if it's 30, we do not stop here because here we have less than 30, and we stop here because we have enough neighbors. Even if we continue a search further somewhere, probably we can find closer vectors, but we need to stop to balance accuracy and query rate. How these parameters influence speed and accuracy? During construction phase, M and EF, the higher value increase accuracy, but index build process is slower. they helps to make index with better quality. And M decrease search rate because index is bigger, and EF, slower, faster. It makes faster. It's mistakes here. Makes faster because index has better quality. And during search process, if EF higher, then accuracy is higher because we considered more neighbors and found more closest neighbors, but search rate later because we processed more data. It's demonstrated on this graph. And we go further. From database point of view, vector is a usual data type. After creation of extension in the vector, we can declare table with a column of vector data types. And when we have vectors in our code, it's represented as a list of numbers enclosed in square brackets, the same as vector presented in Python. When we make lookup in database, we use a EF search parameter. It's EF parameter I told before. We set it to value, and algorithm return up to this value. In this case, up to 100 nearest neighbor. In query, we use order by value and distance operator, Euclidean or angular distance, and limit result to desired number, for example, 10 in this case. This method has one drawback. It was from description of this algorithm in the original article. It's never return more than 100 records. We'll speak later about this. As I said before, Postgres started to compete with other vector databases, and one of the methods to increase query rate is reduce vector size. Usual vector has element float 4. It's float number. We can replace it with float 2 and reduce size of vector by half. This approach allows us to make it without converting original data. We can convert data during index process and create index with half-vec data, but original data remains the same. And we need to convert query making cast to half-vec type. I show benchmark result also later. And if we can increase query rate by reducing size, can we take it further and reduce size to 1 bit? It's intriguing. How we can do? If element is greater than 0, we set it to 1. If it's less or equal to 0, we set it to 0. It's reduced memory requirements by factor 32. And it was shown that it works good if vector has dimensions more than 1,000 elements. And in any case, we have to check our data set because some data sets can have property, for example, of elements are positive and it will not work. It should be checked for every data set. This method is supported by pgvector and pgvector scale. Explain it. Visual slide. We change elements to 0, 1 for one axis and 0, 1 for other axis. It became 0, 0, 1, 0, 1, 1, and 1, 0. The distance of distance between element in one cluster equals to 0. Distance to nearby elements equal to 1, and distance to more distant cluster increases as distance to cluster also increases. This type of distance is known as a Hamming distance. It's counted as a count of position where value differs. Here value the same, here value differs in one position, and here in more position. In this example, in two position. When we create bit quantized index, we also doesn't need to convert our original data. We can encode them only in the index. We use a function, for example, binary quantize, and field with vector converts to binary representation. And we also need to change query vector. And here we have two options. First option is ordinary options, as I show it with half-vec. We add binary quantize function. But this method will result in lower accuracy because we lost precision during this quantization. And we have a second option. We can make search in two steps. We convert query to select from subquery. In subquery, we search for 800, it's example, 800 elements using approximate bit search. And then in outer query, we calculate exact distance, order by exact distance, and limit result to desired number. I show result in benchmark. This table compiled from benchmark demonstrated by Jonathan Katz. He took dataset ZIFT, GIST, DBpedia with 1 million vectors, dimensions 1, 9, 15 hundredths. And you see table size increased according to dataset size. Index size for vector approximately linear. For half-vec, it's reduced by half. And for bit index, it's reduced by 20 times. It's not 32 because index has graph structure and overhead with free spaces, but it's also great. And here is a numeric result. Let's look at half-vec results. Size reduced, amount of information decreased, but accuracy remain on the good level comparing to vector. It's not worse. Result for bit is interesting. For small dimensions, it's poor. Bit quantization should not be used for such data sets. And here is the long data sets, and it's also poor result due to quality of, due to nature of data in these data sets. But for data sets with 1,000+ dimensions, you can see that it's option 1 search without re-rank It's also not ideal, but I hope you see. But for search with re-rank, it's two-step search, latency time is less than vector, you can see, and quality also on reasonable level. It means that for bit quantization can be used for very large databases, reducing index size by 20 times. Index can be accessed quickly and even stored in cache, in shared buffers, further enhancing performance. However, if you start to make even very simple application, you will face situations that you don't need simply nearest neighbors. You need nearest neighbors filtered by some criteria. For example, you need documents with some language code or files created before some date or after some date, or images bigger or smaller. And when you apply this filter to the query, it can happen that this query will not return any result because EF search constant limited the quantity of returned candidates. It's not good because index is designed to accelerate query, not to alter the behavior. To address this issue, we must know the properties of our data sets and properties of filter values. Is the list of these values fixed, or is it depends on user? Is it small, as small as 2.5 values, or as big as 1,000 values? I would explain two important properties of data sets. First is the selectivity. Selectivity is the fraction of points returned by predicate. On the top picture, it's a high selectivity, 50%. You see here data sets corresponding to 2 predicates, and lower selectivity if we have more predicates. And second important property of data sets, it's a correlation, how vectors distribute in the space and this predicate distribute in the space. Upper picture, no correlation, predicates distributed uniformly in the space. Here is a positive correlation. Green vectors cluster to one cluster, blue cluster to other cluster, and here is a lookup vector. It's located inside of cluster where we look, and negative correlation also to clusters, and lookup vector located in around of vectors with other type of predicates. It's important because some algorithms work good with no correlation situation, but stop working in a situation with positive correlation and especially with negative correlation. On this table, I would like to summarize how to query works with different selectivity. One moment. As selectivity drops, quantity of distinct values in the filter increased. Query received less correct values, and in the situation where 1,000 distinct values, this index became useless. And when rows in the table grows, situation became even worse because query time grows as a logarithmic function. And in this situation, vector index stopped working. It can be a situation when we have a lot of distinct values, and in this case, we can use the usual B3 index that can work in this situation. What's the solution? First, partial index. If we have fixed number of predicates, we can create partial index with the same clause as in select, and it will work in this partial case. Second, streaming or iterative scan, it's algorithm that continue return rows until they found all needed rows according to this predicate. It was introduced in previous year in PG Vector in this version, and it's in PG Vector scale was by default. You create index and it's always work. And I already said when regular B3 index is fast, when we have a lot of different values and every combination corresponds to small quantity of vectors, we can try to use B3 index. Multi-column index. Multi-column index can filter predicates before search, and it can solve all problems with selectivity and correlation effectively. And there is a problem now. In open source, there is no one implementation in open source. For example, Postgres Pro has extension, but it's available only to licensed clients. It's how it works. After creation of extension, we can create index including all fields that we need to filter, and then include it to query. And it takes all graphs needed for these clauses and prepare result already. Here is a table with summarizing. Regular index, it's drop accuracy when selectivity drops, more distinct values. Streaming vector index, it work good with no filter, then drops query rate linearly. And multi-column vector index, it works opposite when selectivity increased and quality of search and rate remains on the high level and slower only for less or greater operators. Here you can see in the table or in the charts, quality of the regular search drops, its record drops, and on the lower selectivity it became useless. It's streaming index. It has good accuracy but worse query per second, and multi-column index has much more performance. It's not implementation question, it's a difference in nature of this algorithm. And in small selectivity, streaming has very low performance, and multi-index has very high performance and became as dot here. Here are recommendations. I simply read them. I stay in presentation. You can read if you're interested. And some conclusions. Postgres allows to store large amount of vector data, and in the same time we can use advantages of database as standard API, backup, user management, replication. Postgres now has many extensions in open source. It's possible to control vector types, and it has many index formats. We can choose for our task. And in performance, Postgres now is compatible to vector databases, and while retaining all advantages of databases. And also it has challenges. Still need to improve support for multi-column index. It should be much more multi-column index, the same as Postgres now has for different application, different index. B3 for one situation, GIST for other situation, and GIN for special situation for this. And also improve cost estimation procedures for vector index. Now it's not implemented in smart way. It only return cost, one cost for all situation. It will not help you if you have two vector index in one column. It should be improved. It's all. Question, please.
Thank you for your report. It was very interesting. I have a question. As far as I understand, Postgres still keeps everything in heap tables and in regular indexes and in vol. So exactly we have for about 3 copies of the same data. One for backup, maybe we can say that we have 2 copies because we still have it in index and in the heap table. As far as I understand, actually this data usually is not changing, so we don't need MVCC, and exactly keeping in heap looks like an overhead. Maybe there are some optimizations, maybe in your fork, or maybe they are planned to keep it only in index for non-multiversal concurrency control versions, but for something stable, you put some kind of a file, and after that you can just connect, like for the where, with Postgres and to read from it. Thanks.
First questions about copies. It's really, we have copy of vector in heap table. It's copy of vector in index and in backup. But bit quantized index store only decreased version of this index. It's already plus. And regarding about this overhead, I haven't heard that there is some project about storing in other format. Because as I know, our clients, big shops, for example, they store 100 millions of vector and they update them in the process of their work. And update, and in the same time, for example, every 6 hours, then send 6 million requests to get nearest neighbors from these big data sets. They work and they write and read in the same time to update information about goods and about their clients. It's no.
I'm curious why have like a set of like discrete numbers of like vectors for like different like size. Why not have like a more like dynamic one where like let's say this like a particular data point has like maybe 501 vectors, another one may have like 15 vectors or something like that, where it's like more dynamic and more numbers in between, and maybe like each like a point or each number in the vector can represent more things.
You mean numbers inside of vector?
Yeah.
Oh, if I correctly understood your questions, really we can deal with vectors. We don't know what's inside of these vectors. It's calculated by model. It's we almost never know what's inside. And
I mean, like the number of numbers within the vectors.
It depends on the model. Model originally designed to prepare vectors of specific lengths. It can be designed to make it shorter, to be faster, or longer to have more information inside. And it will be slower. And it depends on models on after of this model. If it has 512, we deal with this length, if I correctly understood you. But I can.
So I have a question about indexing. Now, in terms generally, I assume it's mostly GIST and SP GIST. Which of these two, sort of, where do you see the trade-offs between GIST and SP GIST for creating your vector indexes?
You mean performance of creating indexes?
Yeah, as far as what are the trade-offs of the different index types? I assume they're mostly going to be GIST and SP GIST, but if you use other types, love to hear about that too.
HNSW requires much more calculation efforts, and usually when algorithm written, it works with data set storing in memory. As soon as part of data go to the index, creation time dramatically increases by 100 times in my calculation. And it's two methods to solve it. One of the bit quantization to prepare smallest index, and other approach we used in our company, for example, to split index by clusters. And as soon as memory filled, we stored cluster to the disk and start to build new cluster. And then we need additional procedure to look between these clusters. It's a second approach. It's not written in the articles, by the way, if it's an idea for some of you. And
Okay, that was a great presentation. So thank you very much for that insight on vectors in Postgres. Can we give a round of applause, please? Thank you. Okay, and let's see, just to prepare the next speaker before we get to lunch. Is he in the room? Mr. V, there we go. Thank you. Why don't you come up? We'll get you set up already.
Showing time.
Oh, no worries.
It's what I needed.
So we're just going to take a couple of minutes to set up before our next speaker. So we're waiting for setup. I would like to introduce our friend here, V. Today he's going to share with us about the Postgres extension that enables full text searching on almost every known human language. So everyone, please, a big round of applause to V on stage. Thank you very much.
Good afternoon. I'm V. I'm a software engineer who mainly work on building data pipeline, and I also work on multilingual text processing for more than, let's say, 20 years. I speak Thai, English, and Lao because my grandmother speak Lao. My ancestor came from Laos more than 2 years ago. I tell you because my wife told me that I should tell something about my personal life, which is, I think it's enough. First, I will tell you a bit about why I make this extension and tell you about similar extensions and also how we make this extension and the future work. There are a lot of applications, open source applications that already use Postgres full text search. For example, CCAN. Maybe you have already used one of them. And this course, which is very popular. And the most important, I also use Postgres for full text search. However, Postgres SQL full text search does not support multilingual text by default. For example, it doesn't support Thai, which doesn't have space between words. And we also want to customize the tokenizer in the way that we want, because usually, even I implemented the full text search, user or some stakeholder usually ask me to modify the search result, and the cost of unsatisfied search result is usually came from the tokenizer. And in the future, maybe we may have we may have a requirement to put character in many languages in one word. For example, this one, the first character is Thai, and next one Latin alphabet, and mix it with Arabic letter. Maybe we have to do that in the future. Now this is about related work. First one is PG Search Thai. As its name suggests, it only enables Thai search, not any other languages. And it made by Sadike with he do not maintain this project anymore, so we cannot use it with current version of Postgres. It has been made 11 years ago. PG Search is another project, but this one is slightly different because they use external search engine. The first one, PG Search Thai, is just a customized version of parser. And the last one I cannot pronounce, but I don't know how to pronounce it. It's also similar to PG Search, but they use the different search engine. I checked full text search in Postgres. It has been enabled since 2002, but the default parser, which is called T-parser, doesn't support many languages. especially Asian languages. So we need some more extension. So I introduced this one, Chamkor PG. Chamkor is the name of a district in my hometown because I'm too lazy to name thing. Maybe this is I cannot see a culture site. 10 minutes left? Okay. Chamkor PG is only a parser. We do not implement the whole search engine. We just try to analyze the text, only the part of text. And we want to support many as language as possible. And we want it to be easy to customize just by editing a text file, not run the compiler or something like that. Okay, PG Search is created 11 years ago. I wanted to use it with new version of Postgres, but I cannot, so I decided to port it to Rust and change the word tokenizer to Chamkor because I want it to support more languages and to make it more easy to customize. Why we use Chamkor is it's fast, it's customizable. Here I compare it with another Rust implementation with similar algorithm using this command on the Hessner computing instance a few years ago. And Chamkor is about 2 times faster than another one. About customization, we do not put something very specific to Thai language into the source code. Instead, the language-specific knowledge is put in dictionary or just a word list and the rules. Here is the example of the thing that we want to customize. Sometimes we want, some people may want to split these 2 words, C and dang, color and red. Someone want to put it into the same unit. So we allow it. The word list, we can put any word into the word list. Don't have to compile or put it in special format. And the word list look like this. On the top is Thai and lower is Lao. And we also can mix a lot of languages into one word. And here is some rules. We have replacement rules, which is very, very simple. We have pattern in regular expression and the result, and we can put any language. And here is cluster rules. Is the rules that define which character should be put together at the same unit. And here is the rules for Khmer, the language of Cambodia. Anyway, we have backup plan. If Chamkor doesn't work, we have this project, Mangavika, which use ICU. You can download it here. If you don't want to customize anything, just use ICU. And future work, I want to maybe port some parts back to C because it is simpler to make extension in C and maybe build the interface from the Chamkor, which is more friendly to C. and maybe put some rules and word list in table. And I want to also make it compatible with managed database, because nowadays most of people doesn't install Postgres on by themselves anymore. Thank you.
I don't know if your product is the right place to deal with this, but how do you deal with stemming for like Latin-based languages like English?
Oh, I did not cover it. Did not do anything about it yet.
You showed that you use patterns in your settings, and did you measure the performance of these patterns? For example, I faced the situation when patterns in standard library works very, very slow than in other libraries.
Actually, the pattern is not my idea. It is research was published in SNLP in the year 2000, and it improved the accuracy, and the speed is not very poor compared to LSTM.
Yeah, hello. Thank you very much for your report. It was very interesting. I have just opened your GitHub and looked at the product. I have looked at the source code right now, and I have a question. Why don't you use, for example, PGRX or something like this, some well-known wrappers about the C headers, and you implement them yourselves? What is the reason for it?
I don't use PGRX because I can't. There are some types that is not supported by PGRX.
You mean that you have to rely on some symbols that are exported by Postgres but are not listed in PGRX, yes?
Correct.
Okay, thanks.
It looked like you had a follow-on question, but obviously something that Postgres needs to support more languages. Any other questions? Okay. Then we take it there. V, thank you so much. Very insightful. Helpful.
Thank you very much. Thank you very much, everyone. So we can take a break. We have dedicated also another session for lunch, and proudly sponsored by AWS and Fujitsu. And thank you very much. And please don't forget to come back at 1:30 for more interesting talks. Thank you very much.